Autonomous vehicles are cars that operate by sensing the road, traffic conditions, and surroundings through sensors, cameras, and radar systems. They have emerged as one of the forefront technologies in recent times and are expected to play an even bigger role in the future. In 1939, Norman Bel Geddes created the first driverless car, which was an electric vehicle controlled by radio waves and embedded with metal spikes on the road. In 1958, the concept was realized by a manufacturing company. Today, driverless car technology incorporates radar, GPS, odometry, and computer vision systems to navigate in traffic. During automated driving, autonomous vehicles accurately and quickly perform maneuvers such as steering control, deceleration, and acceleration by determining the positions of braking and parked vehicles using sensors. These sensors, equipped with distance measuring capabilities, detect and perceive objects including live beings, pedestrians, and traffic signs using cameras. Autonomous smart vehicles in their stages Level 1, driver assistance, includes features such as speed control, road control, and automatic braking through sensors. Level 2, partial automation, adds features like acceleration and vehicle control. Level 3, conditional automation. At this level, vehicles autonomously ensure environmental control and can self-drive up to a certain speed. Level 4, high automation. The car performs decision-making actions such as braking, full steering control, speed reduction or acceleration, tracking the vehicle and the road, changing lanes, turning, and signaling. Level 5, full automation. Complete control is in the hands of the vehicle. Creating a new ecosystem with autonomous vehicles, autonomous driving and related services will become an integral part of our lives. While autonomous smart vehicles become one of the most invested areas within the automotive ecosystem, they have also fostered the development of e-mobility. Currently, there are over 30 million driverless vehicles worldwide. Autonomous driving creates significant value for consumers in terms of customer loyalty, financial products, and insurance. Within the automotive industry, we anticipate the emergence of new formations involving services, supply, infrastructure investment, R&D activities, the development of new sales and business strategies, acquiring new technological capabilities, and addressing security concerns, particularly through software and mobile operators. Changing consumer experience and forming a new service model. Autonomous driving not only offers commercial and technological viability but also creates an important new ecosystem for drivers, the automotive industry, and society as a whole. Consumers experience a different kind of mobility, making driving safer, more comfortable, and enjoyable through continuous communication between autonomous vehicles and sensor systems on the road. One of the significant advantages of autonomous smart vehicles is the ability to engage in other activities while driving in heavy city traffic. It offers opportunities for attending meetings, watching movies, and even working. Furthermore, these vehicles can provide mobility options beyond public transportation or car-sharing services for elderly drivers. The increased adoption of advanced driver assistance systems in Europe is projected to reduce the number of accidents by approximately 15% by 2030. Autonomous cars can have significant cascading effects on other industries. Smart autonomous vehicle technology can reduce the need for roadside assistance and repair by decreasing the number of car accidents and collisions. It can prevent consumers from paying high insurance premiums, giving rise to new insurance models. Automobile manufacturers offer personalized offers as they experiment with new insurance products. They tailor insurance policies to individual consumers, providing a significant advantage. The autonomous smart and connected vehicle market will grow by 2030. 20% of passenger cars sold will include autonomous technologies, and this figure is expected to reach 57% by 2035. The market is projected to grow at approximately 40% annually between 2030 and 2040. Manufacturers suggest that autonomous driving could generate revenue of around $400 billion by 2035. The market's annual growth between 2030 and 2040 and its contribution to a total value pool of approximately $1.7 trillion are expected. Sustainability steps remain crucial in the new ecosystem. Studies show that transportation accounts for about 30% of global carbon emissions, with 72% of these emissions coming from fossil fuel-powered vehicles. Autonomous driving changes people's perceptions of urban mobility, making shared mobility more affordable, greener, and more livable. Manufacturers are working on reusing, recycling, and providing access to vehicles after the end of their useful life, just as they do with key components in electric vehicles. On the other hand, cities and local authorities should invest in traffic lights and signs that are compatible with autonomous driving, making roads suitable for autonomous driving. Furthermore, practices such as imposing additional taxes on traditional vehicles seen in major cities in many countries, providing special free parking spaces for electric vehicles, should be expanded. As governments continue to provide incentives for e-autonomous smart vehicles, expanding charging networks and supporting mobility service providers will be crucial for the development of the system. From a sustainability perspective, with advancing technology and consumer expectations, it is not too far off when shared autonomous vehicles and autonomous public transportation services become affordable, more ecological, and efficient in major cities. Public transportation can reduce energy consumption in all aspects related to traffic and enhance urban quality by becoming more environmentally friendly.